Hello, guys. Welcome to Gramta Solutions and welcome to your grade 12 mathematics. This is a past paper series of differentiation calculus, and the first video to begin our session is the differentiation calculus questions. Remember, it's all of them: differentiation rules, application, and the cubic graphs as well. Okay, so this question paper is from the Eastern Cape. It was written in June 2024. Okay, it was written in June 2024. So without any waste of time, let's open the paper. Okay, here is it. Let me pin it. Right, pin it. All right. Now, all right, let's start. So, as is the case, or as is the norm, I want to read few instructions that I will be using. So what we are saying, one, remember instruction 3 says clearly show all calculations, diagrams, graphs, etc. that you have used in determining your answers. And then instruction number 4 says answers only will not necessarily be awarded full marks. Okay, so that means try to show how you got to your answers. And then instruction number 6 says, if necessary, round off answers to 2 decimal places unless stated otherwise. And of course, because this will include graphs, I want you to remember that diagrams are not necessarily drawn to scale. Okay. And one that I know a lot of us struggle with, write neatly and legibly. But I know all of you guys write neatly and legibly, right? Okay, perfect. Now let's get into it. So I believe we will start. I'm not sure. This is a June exam. So normally it's 7, 8, 9, 10 or 7, 8, 9 or 8, 9, 10. But let's see. Maybe it might be in here. It might be 7, 8, 9. Okay. Question 7. Perfect. All right. So this is now in question 7. We will begin with question 7. So question 7. 7.1, it says, determine f prime x from first principles if f of x is equal to half x squared. I'm going to take you to your formula sheet so you see the formula that you need to use. Okay, but of course, if you know it, you know it. So this is the formula that you need to use. Okay, but if you know it, you know it. So, by the way, for those that are using mobile devices, guys, please rotate your screen so you have the best viewing. Okay, so 7.1, let's proceed. F of x is equal to half x squared. Now, we need to get f of x plus h. We need to get f of x plus h. What will it be? It means where there's x, you put x plus h. Okay, this then we need to simplify it further. It will become, using the FOIL method, it will become x squared plus 2xh plus h squared. Now this becomes half x squared plus xh plus half h squared. Okay, now we can find our f prime of x. F prime of x is the limit as h tends to 0 of what? Of f of x plus h minus f of x all over h. So what is this? This then becomes the limit. Remember, we will need the limit as h tends to 0. Where there's f of x plus h, we will write this expression as is. What is it? Half x squared plus xh plus half h squared minus, what is f of x? It's half x squared. It's half x squared all over h. Right? Now, as you can see, the half x squared get cancelled. So what are we left with? Going to the next page. We are left with the limit as h tends to 0 of what? Let me go back, of xh plus half h squared. xh plus half h squared all over h. Highest common factor in the numerator is h. So I'm factorizing it in other words. So h is a common factor. We are left with x plus half h all over h. As you can see, the h's will cancel. We are left with a limit as h tends to 0 of what? X plus half h. Alright? Now we have to substitute where there's h, we put 0, because right now we can substitute where there's x, we can put 0. We couldn't earlier because there was an h in the denominator which was going to affect us. But now we can substitute. So it will be x plus half, where there's h, we put 0. Now this becomes h. Okay, this becomes h. So, not h, x. Okay, this becomes x. By the way, because I believe when you're watching this video, you have done differentiation rules. When you look at 7.1, you can do it using differentiation rules that you know, so that to prove if differentiation from first principles gives you the correct answer. Yes, the expectation here is x. So this is very correct. Okay, perfect. Now 7.2.1, we are looking for f prime x. If f of x, let's see, f of x is half or 1 over 5, or we don't even have to write it down. We don't have to simplify it. We're done. So I can simply say f prime x is what I am going to do here. For those that sometimes struggle with this, I'm going to say, we're going to say this is 1 over 5. You drop the 5. Remember, you drop the 5, okay? And you minus 1 from that power that you had, okay? Minus 6, you drop the negative 2, okay? You drop the negative 2, and in that power, you subtract 1, okay? So what do you have? 1 over 5 times 5, you're left with 1. So this becomes x to the 4. Negative 6 times negative 2 becomes positive 12. So this becomes x to the negative 3. So this is it. You can leave it here. It's okay. All right. You can leave it here. It's okay. All right, guys. This is your first derivative. Okay. Perfect. 7.2.2. You are given d of x plus root x square dx. You need to simplify what's inside the bracket first before you differentiate. So let's simplify it. It'll be x squared, okay? It'll be x squared plus 2x root x plus x, okay? This is us using the FOIL method. For those that might be wondering how, it's like saying this bracket multiplied by itself, okay? So FOIL method, it gives you this, okay? Happy? Perfect. So before I proceed, I also need to simplify this guy here further. So I'll say d dx of x squared plus 2x. Remember, guys, square root is a power of half. So this will be 1 plus half, which is 3 over 2 plus x. Okay, 3 over 2 plus x. Now, because we want to differentiate, we will drop the d dx. So what does it mean? We differentiate this. I will differentiate it like I did here. For those that might be struggling with differentiation, remember the aim here is to give you all your distinctions. But if your differentiation is good, you can directly get to your answer. Okay, let's go. So I'm dropping it. It'll become, let me remind myself, x squared. So it'll become 2x 2 minus 1 plus 2x, oh, not 2x as yet. What was the power? The power was 3 over 2. We drop the power. Oh, what am I doing? We drop the power. The power is 3 over 2. We have x. It becomes 3 over 2. All right, 3 over 2 minus 1. And we go back. Or plus x. So plus x, it'll be, obviously, it's 1 that is being dropped because it's power 1. Then we will say we have 1 minus 1. What is this? This is 2 to the x Now this 2 and the 2 are cancelling. You're left with 3x and a half, I believe, and a half, right? And a half plus 1 x to the 0. This step, let me maybe highlight it with a different color. I'm highlighting it with a different color. However, our final answer is 2x plus 3x to the half plus 1. Okay. There are those that can get this answer directly without doing what I just did here. Remember, the aim is to get you all your distinctions. Okay. So this is it, guys. This is your first 10 marks. Okay. This is your first 10 marks. Now, let's go to the next questions. Question 8. Question 8, we have f of x equals, let's see, 8.1. F of x equals negative x cubed plus 12x minus 16. 8.1.1. Show that x minus 2 is a factor of these guys. So to say that we must show that x minus 2 is a factor of this guy, it means that we have two ways of doing this, guys, okay? We have two ways of doing this. So I can say this, therefore we must find what is x of 2, f of 2, right? We must find what is f of 2. What is f of 2? What does x? We put 2 minus 2 cubed plus 2 into 2 minus 16. Okay? Is it minus 16? Oh, sorry, plus 12, my mistake. Plus 12, right? So what are we getting? We're getting this to be 0, isn't it? This will be 0. All right, guys? This is 0, isn't it? So when we get this to be 0, we can therefore conclude and say, therefore, x minus 2 is a factor of f of x, isn't it? Remember, if something is a factor of an equation, that equation will be, when you substitute whatever value, it will be 0. Okay? Because if x, what it means here, your root will be x equals 2. So where does x you put 2? If it gives you 0, you must know that x minus 2 is a factor. Otherwise, you can also use factor theorem. Okay? You can also use factor theorem. It'll still give you the answer. Okay? All right. Moving on. 8.1.2. Determine the x-intercepts of f. Determine the x-intercepts of f. So that means we must say f of x must be equal to 0. What is f of x? Minus x cubed plus 12x minus 16 is equal to 0. Okay, so what I know is that we can try to divide by negative, in fact, negative 3x by negative 1, so it will become positive 3x minus 12x plus 16 equals 0, isn't it? Now what do? We found a factor which was x minus 2. It was a factor. So I'm going to say leave space x squared minus leave space x minus leave space close equals 0. X cubed divided by x is x squared. Okay, cool. The middle 10, or rather this 10 is supposed to be, as you can see, we don't have an x squared 10. So already you have positive, what is this? You have negative 2x squared. It means you need what do you need? You need a positive 2x, right? Because negative 2x squared plus positive 2x squared will be 0x squared. Then we are good to go. All right. Now, 16 divided by negative 2 will be negative 8. And this is it. This is us saying we are good to go. Now, let's further factorize. We're going to factorize this part because it seems like it needs factorization. Okay. Remember, guys, with factorization, you don't have to use the method I used. If it's difficult for you, you can use that one of your factor theorem. It's still okay. All right. Let's go. We have x minus 2, and that will be x, and we go there. It will be x minus 4, and then x minus 2 equals 0, but let me confirm. It'll be x plus 4. It'll be x plus 4 and x minus 2. So x equals 2, or x equals negative 4. Even if you don't write this x equals 2 twice, it's okay. Right? Even if you don't write it twice, it's okay. So these are the critical values, x equals 2, and are they critical? They are the intercepts. X equals 2 and x equals negative 4. Okay, they said they want the x-intercepts. You can leave it here, or you can give it coordinates. It's okay. All right, perfect. Now, 8.1.3, determine the coordinates of the turning point of F. With what I have seen that one of them is also a turning point. This value here, it seems like it's also a turning point because I see it's repeated. Do you see that? It's repeated. So it means it's also a turning point. But it's okay. Let's see if indeed it is. So we need to find first derivative because we need stationary points. So first derivative of this guy is negative x cubed. Oh, it's negative 3x squared plus 12. Okay, it's negative 3x squared plus 12. Now we need to equate the first derivative to 0. It'll be negative 0 equals negative 3x squared plus 12. All right, so this is similar to saying 3x squared minus 12 equals 0. So x squared minus 4 equals 0. We can therefore say we have x minus 2 and x plus 2 equals 0. Therefore, what are we looking for? We're looking for x equals 2, or we're not looking. We got x equals 2 or x equals negative 2. Already, you know that f of 0, you calculated it. F of 0 already, you know it's what? It's 2. Now let's look for f of negative 2. Take out your calculator. In other words, what I mean, I'm going to write it in red. What I mean is, you will say where there's x, you put negative 2. Be careful. Press these things the way that I have written them down, okay? Negative 2 minus 16. Okay, so let's go. This is minus 8 minus 24 minus 16, I believe. So what is our answer? Right, let's see. Negative x cubed. Oh no, it's gonna be positive. It's gonna be positive. So it'll be, it's gonna be positive. So it will be negative 32. So what do we have? We have 2 and 0 and negative 2 and negative 32. This said we must determine the coordinates of the turning points of F. We are good. So they are 2 and 0 and negative 2 and negative 32. Okay. All right. Perfect. Moving on. 8.1.4. As you can see, guys, A is negative. This means your function ends with a frowning face. Okay, it ends with a frowning face. So determine the graph of F, clearly indicating turning points and intercepts with the x-axis. I know the x-intercept. Okay, so it's fine. Let's see. I know the y-intercept as well. So we have minus 2. Oh boy, minus 4. Let me say that. Minus 4. Minus 2. 0. We have 2. And then a vertical scale. Let's say we have minus 16. Minus 32. X-intercept was x equals negative 4. Turning point was minus 2 and negative 32. Y-intercept was 16. And then turning point was 2 and 0. Remember, I said it ends with a frowning face. So this is your function. Okay, this is your function. Here is it. By the way, do not forget to indicate y, x. Then this is it. This is your graph. Okay, this is your graph. This is all your 3 marks. Okay. Now, determine the equation of the tangent. Determine the equation of the tangent to the point of inflection. So they say equation to the tangent. Did you hear this? The equation of the tangent at the point of inflection. So we need to know what is the point of inflection. So in order for us to know the point of inflection, we are going to 8.1.5. It'll be f of x equals, not f of x, but f double prime. Okay, f double prime of x. It'll be, what will it be? It'll be, okay, let me remind myself what f prime x was. F prime x was negative 3x squared plus 12. Now, what is f double prime? F double prime is negative 6x. Okay, it's negative 6x. Okay, so I'm going to equate it to 0. Okay, I'm going to equate it to 0. So what is this point? This point here is x equals 0. What is f of 0? F of 0 is simply negative 16. Now, remember, guys, this is the tangent. Okay, this is point of inflection. The point of inflection is at this point, x equals 0 and y equals negative 16. Okay, but you don't know the gradient of the tangent. So now let's find gradient of the tangent. So gradient of the tangent. So remember, gradient of the tangent is gradient at a point. What is gradient at a point? First derivative at what? The point was 0. So here is it. So what is it? What is first derivative? Here is it. It's negative 3 into 0. Okay. Negative 3 into 0 square plus 12. What is it? It is 12. This is your gradient of the tangent. Therefore, we will say this is, so equation of tangent, let me just write it down. Equation of tangent will be, I'm going to use gradient point form, y minus 1 equals m into x minus x sub 1. The point we have here is 0 and negative 16, isn't it? Isn't it? Is it 0 and negative 16? Indeed, it's 0 and negative 16, right? So where there's y, where there's x, you put 0. Sorry, where there's x1, you put 0. Where there's y1, you put negative 16. So this is y minus 16 close equals, what was the gradient? It was 12. What is x1? 0. Okay, going to the next page, we will have y plus 16, but let me turn the page. It'll be y plus 16 equals 12x. Therefore, our tangent has the equation 12x minus 16. Okay. It is 12x minus 16. Happy? Perfect. Now, 8.2, it's one of the most interesting questions. 8.2, it's one of the most interesting questions. The graph of P prime X is given below. As you can see, this is a thingy. What do we call this? It's a quadratic, what you call a parabola. Okay? And it's a smiling one. So if it's a smiling parabola, you expect your first derivative to be a smiling parabola, and that means your cubic must end with a smiling face. That means A is positive. So now, they say for which value of x is the graph of P of x increasing? The graph of P of x is increasing when this P prime x is greater than 0. Okay, it is increasing when P of x is greater than 0. So to answer my question, remember I'm saying it is when P prime x is greater than 0. So where is it greater than 0? Now what you can see here is that all values of x are greater than 0, but be careful. Therefore I will say this is when x is an element of real numbers. However, x is not equal to 0. Okay, it can take all x values you can think of, positive or negative. As long as that value is not 0, you are good to go. Okay? Now, 8.2.1 9.2, it's saying to you, for which value of x is the graph concave up? So for the graph to be concave up, let me remind you, this parabola is smiling. So its cubic must also end with a smiling face. Where is it concave up? It's concave up from the point of inflection, rightwards of the point of inflection. Now, what is rightwards of the point of inflection? When you look at this parabola, the point of inflection is what you refer to as the axis of symmetry. So what is our axis of symmetry? X equals 0. So to answer this question, the graph of P of x is concave up when x is greater than 0. Okay, when x is greater than 0. Maybe let me show you this as well. Okay, when x is greater than 0. Okay, so this is when x is greater than 0. This is when it is concave up. Okay, guys. So this is it. This is how you attempt these questions. Okay, this is how you attempt these questions. All right. Now, I know that there is an application question. Let's go there. Question 9. In the Northwest, they say, Poto yabo robo. Now, let's see now. In the diagram below, ABCD is a square with side length CD equals 200 centimeters. PQRS is a rectangle with vertices on the sides of the square. PB is equal to PBQ is equal to SD is equal to DR is equal to X centimeters. So these guys here are X centimeters. Okay. Nice. Now, 9.1. Guys, this is one question. I looked at it and I'm like, ooh, Eastern Cape, you had it easy. But of course, you should have it easy. Now, show that area of the rectangle is given by that. It's okay. I'm going to tell you now. When you look at this triangle PBQ, all right? So I will say PBQ. Basically, we can find PQ. Come on. PQ is supposed to be, according to me, it's supposed to be 2x squared. Right? Is it 2x squared? Yes, I think so. It's supposed to be 2x squared. And I will leave it here. Guys, this is Pythagoras. If you are wondering why I'm saying that, it's because I'm saying PQ is equal to PB squared, which is x, and then PB, which is x, and then PQ, which is also x. Hence, I'm saying this. Okay, perfect. Now, let's look at SP. First thing first, I want you to understand that AP will be equal to AS will be equal to CR will be equal to CQ will be equal to this length or this length. Generally, it is 200 centimeters. However, x centimeters was cut, so it is 200 minus x. Are we together? This is 200 minus x. Therefore, you guys should then agree with me when I say that, okay, we can therefore say PS, somebody remembers the chocolate, PS will be this guy squared plus this guy squared. These are the same guys, so why don't we say it's this guy? Oh, yeah. Right? It's 2, and then 200 minus x all squared, in case you are confused. So we will say PS is equal to square root of what? AP squared plus AS squared. What did we say these guys are? 200 minus x all square plus 200 minus x all square. Right? So as you can see, it's two of the same thing. All right? I don't want to simplify as yet, guys. Okay? I don't want to simplify as yet. Okay? So I'm not simplifying as yet. I'm leaving this as is. All right. Now, so I'm leaving this as is like this. So now, let's answer the question. Area of a rectangle. So area will be, as you know, area is length times breadth, meaning PQ times PS. What is PQ? You said it was 2x squared. And then what is PS? You said it was 2 times 200 minus x all squared, isn't it? Now let's see. These are all under a square root. If you like, guys, these are all under a square root. You can write them as 2x squared. In fact, 2 times 2 will be 4. So let me write it as 4. Okay, let me write it as 4x squared. And then 200 minus x all square. Now, square root of 4, because these are products, square root of 4 is 2. Square root of x squared is x. Square root of 200, what is this? Let me see let me check something here. Okay, minus. Okay, minus. Right, I think it's okay. It's perfect. Yes, it's perfect. Now, square root of 200 minus x all square will be, the square will be killed by that. So what are we left with? We are left with, as you can see, what you are supposed to prove has taken the 2 outside. So it will be 2 open bracket 200x minus x squared. Okay, and this is you proving 9.1. Okay, perfect. All right, now let's see. 9.2 says, determine the value of x for which the area of the rectangle will be a maximum. I understand why they say a maximum, because this is a parabola that is frowning. Let me show you why I'm saying that. This is similar to saying 400x minus 200x squared. Can you see that? It's a frowning parabola. So this value here is what you call a maximum. Okay, perfect. Now let me answer this question. 9.2, let's answer it. For the area to be the maximum, we'll say, let me say dA dx. What is the A dx? First, I want to write A in this form. It is 400x minus 2x squared. Now, what is the A dx? It is 400 minus 4x, isn't it? 400 minus 4x. Remember, that which you are differentiating equated to 0, and then this is 0 equals 400 minus 4x. Therefore, we can say 4x is equal to 400. Conclusion, x equals 100 centimeters. So the value of x for which the area will be a maximum is 100 centimeters. So area is maximum if you like. Therefore, area is maximum when, but you don't have to write this conclusion. Area is maximum when x is 100 centimeters. The reason I'm saying you don't have to write it is because it's the only value you are getting, right? Perfect. Now they say, what is the ratio of the maximum area of PQRS is to area of ABCD? Okay, so let's find maximum area of PQRS. 9.3, maximum area, okay, A max, we called it A max, so A max, what was it? It was 400 into 100 minus 2 into 100 square. Let's get the value, guys. Let's get the value. By the way, remember this 400 blah blah is this equation here, right? It was this equation here. So let's see. 400 into 100 minus 2 into 100 close square. What is it? We have 20,000, right? We have 20,000, be careful, 20,000 centimeter square, because it's area. Okay, perfect. Now, what is area of, now we're looking at area of ABCD. Area of ABCD. ABCD is a square. It'll be 200 squared. So 200 squared, it's 40,000. It's 40,000 Therefore, area of PQRS, of course, it's area A that we calculated, is to area of A, B, C, D is equal to what? Because I won't have enough space, I'm just going to write here, is equal to that one. We said it was 20,000, by the way, square centimeter. That's 20,000 square centimeter is to what? 40,000 square centimeter. So what is this? This is 20,000 goes once into y, goes twice into, 20,000 goes twice into 20, once into 20,000 and twice into 40,000. This is similar to saying 20,000 over 40,000. So the area is, the ratio is 1:2. And this is how you attempt these questions. When you have done this, you will come out tops, and trust me, you will have made the best of this question. You were supposed to spend, let me see, 30 minutes. So 39 minutes into this question. Okay? You're supposed to have spent 39 minutes into this question. Oh, and it seems like we spent less than that. Wow. Okay. So guys, this is how you attempt such questions. So this is it. And if you enjoyed this video, you can subscribe, or please subscribe on our YouTube channel. You can like, and you can also share the video with your friends, classmates, and everyone. And if you want to get in touch with us, you can visit our website, rentalsolutions.co.za. And on the very same website, you will see these icons here. You can click on them if you want to email us. You can click on these three if you want to follow us on your favorite social media. Okay. And if you also want a tutor, you can contact us and we will gladly assist you. So with that being said, ours ends here, and all the best. So bye-bye.